So our quiz for packets and protocols had only a few questions. According to the Internet Protocol, what information is contained in a packet? Is it all the data being transmitted? Is it all the data being transmitted as well as some information about the data, some control information? Is it a small chunk of the data being transmitted, or is it a small chunk of the data being transmitted as well as some control information? It's D, absolutely correct. We are going to transmit some of the information. We're going to break our whole amount of data into smaller chunks that we call packets. But we also need to know where it's going, who it's coming from, all of the other extra information about where to send it. So D is our correct answer. A user enters a web address in a browser and a request for a file is sent to a web server. Which of the following statements are true about how the file is sent to the user? The file is broken down into several packets for transmission. The packets must be reassembled by the user's device upon receipt, or the user's browser must request each individual packet in order until all packets are received. So let's look at each of these individually. Must the packet or must the file be broken down into several packets? Yes, that's definitely true. Anytime we send any message, we're going to want to do a breakdown. Must the packets be reassembled on receipt of the packets? Also, yes, we do need to make sure that they get put back together in order. Now, is the user's browser going to request every single packet one at a time? No, absolutely not. That would take it much longer. What happens is the server splits all the packets up and then shotgun blasts them all into the internet. They all make their way to the recipient, at which point, using those TCP values, using the numbers we have assigned to each one, we can put them back together no matter what order we receive them. So only 1 and 2 are correct here. And question 3, 2 different devices built by different manufacturers and running software built by different companies are both connected to the internet. Which of the following best describes the ability of these 2 computers to communicate with each other across the internet? They cannot communicate since they're built by different manufacturers and running different software. They can communicate, but only if the information is encrypted. They can communicate directly because internet communication uses standard protocols that all devices on the internet abide by. Or they can communicate through an intermediary device that translates packets from one device into packets that are reasonable to the other device. I think I touched on this during my discussion last class. Those 2 devices are able to communicate directly with one another. Does not matter who made them, does not matter what operating system they're running. Since all communication on the internet uses those standard protocols, every device can communicate directly with every other device. All right, let's look at our cybersecurity questions. Which of the following is a true statement about digital certificates in web browsers? Digital certificates are used to verify the ownership of public keys used in secure communication. Digital certificates are used to verify the IP addresses of websites. They're used to verify that the connection to a website is fault tolerant, or they're used to verify that every packet sent in a transmission made it to the final destination. Wow, 2 of these don't make a lot of sense. Making sure the connection is fault tolerant, that sequence of words doesn't really have any meaning. Digital certificates are used to verify that every packet made it to the final destination. That is not true. Digital certificates are used to ensure that we're actually getting the right IP address when we are asking for it. So I believe it's this one, but if I'm wrong, I'm wrong. This was not covered in our stuff that I had to learn to teach you. So digital certificates, they ensure that we are communicating with the right person. So they make sure that we have the right public key for the website that we're trying to send a message to. So there we have it. Oh, let's clear my annotations. Which of the following activities poses the greatest personal cybersecurity risk? Entering your password to log in to a website encrypted over HTTPS, emailing your bank account number to an online vendor to purchase a product from them, providing your email address when taking an online survey, or downloading a free text editor program on the internet. One of these involves finances in a very unsecured way. If we are emailing a bank account number to someone, that seems very, very insecure. There's lots of different ways that that could be exploited. Someone could intercept that email. The person you're sending it to could just take it and do whatever they want with that bank account number. This is a super duper insecure way of communicating online. That is a huge cybersecurity risk. Now, which of these poses the least potential cybersecurity risk? Clicking on a link in an email from an unknown sender, sharing your device's private key used for encryption, sharing your device's public key used for encryption, or using a credit card to make an online purchase on a website that does not use encryption. Well, like we talked about last time, when we have this public and private key encryption, your public key is public. Anyone can access it. So if you share your public key for encryption, that doesn't matter. That's already happening anyways. This is definitely going to pose the least risk. Which of the following are true statements about phishing attacks? Phishing attacks are characterized by communication from one person trying to trick another person into divulging personal information, or they can only be defended against using data compression. Option number one seems like it makes a lot of sense. Option number two, however, that data compression, I don't think would have anything to do with someone trying to trick you. So I think only one is the answer on that one. Question 5, which of the following activities has the greatest potential for compromising your personal privacy? Sharing your device's IP address, switching a device from IPv4 to IPv6, sharing your email address, or sharing the cookies stored in your web browser. I don't know, I know we didn't really talk about cookies, but cookies are information stored by a web browser about your browsing history. That could possibly include things like what websites you've been to or login information. So sharing your cookies is definitely going to be the greatest risk out of these things, because you could potentially share information that is used to log into different websites. Which of the following are true statements about distributed denial of service attacks? DDoS attacks compromise a target website by flooding it with requests from multiple systems. They are carried out by a large group of computers. They can be prevented using encryption. Well, let's one by one go through these. Does a DDoS attack compromise a target website by flooding it with requests? Yeah, that's the primary way that it works. Is it carried out using a large group of computers? Yeah, that's what the distributed part of DDoS stands for. And can they be prevented using encryption? Not really, no, that doesn't make a whole lot of sense. So only 1 and 2. A user's computer is communicating with a website securely using asymmetric encryption. The user's computer is encrypting and sending a message to the website. Which key will be used to increase which key will used to encrypt the message? Will we use our public key, our private key, or their public key or their private key?
Their public key.
We're going to use their public key. So we want to send a message to the website, And we want to make sure that we're sending the message that is encrypted with the key that they can use to decrypt. So we're going to encrypt with their public key so that they can use their private key to decrypt. All right, a user's computer is communicating to a website using asymmetric encryption. The user's computer is encrypting and sending a message to the website, which key will use to decrypt the message. I kind of just answered this. The website's private key will be used to decrypt because we use their public key to encrypt the message. All right, same start. Website and computer are communicating. The website is encrypting and sending a message to the user's computer, which key will be used to encrypt the message. Here, we're going the other direction. The website is sending us a message, so the website will use our public key. And when we get that message, we will use our private key to decrypt it. All right, question. Computer A is communicating with computer B securely using symmetric encryption. Computer A is encrypting and sending a message to computer B. Which key will be used to encrypt the message? Computer A's public key, computer B's public key, a key that is randomly generated for each transmission, or a private key that both computers share. With symmetric encryption, we are going to have a shared key across both devices that we can use to perform both encryption and decryption. So if there was a follow-up question, which key will we use to decrypt the message? It would be the same answer, a private key that both computers share. And there we have it. Query. Is it more helpful for me to go over these together, or is it more helpful for you to take them and then we go? If I just went and started doing the next sequence together, is that more helpful, or is it more helpful for you to take them, understanding what the questions are, and then we go over them together? All right, then I will just say